All right, so yesterday we started talking about logarithms. Okay, we did section 7.2. Today we're going to continue with 7.3, which is on some other properties of logarithms. You're not going to need, I don't think you're going to need a calculator for most of this. We're going to learn how we can take logarithms that are separate and combine them, or ones that are combined and split them apart. And we'll start out with some special patterns that come up. In fact, you'll recognize one of the patterns from your homework last night. Okay. This is a special pattern. Okay. There's nothing to really prove here. It's just a special pattern when you have something, if you had numbers, would be like this. If you have a number, and then in the exponent you have a log, and the base on that log is the same as the other base. So these two numbers match, just like I've written right here. 3 raised to the power, log base 3 of 12. Well, when these two things match, basically what happens is they cancel out. And the answer that you get is what's sitting right there. There's no work to really show for this. It's just a special pattern. All right, so as long as these two numbers match, like they do here, everything cancels out, and the answer that you get is what's sitting right there. So what would be the answer to this problem? 12. Yeah. That's it. Okay, just a special pattern that comes up.
It's not brain surgery?
No, that's not brain surgery. Now, if you change one of these 3's to a different number, then that messes everything up. All right, those have to match, and then they cancel out. Okay? I think that might be similar to the one you had in your homework. Okay, here's another special pattern. Okay, an example of this might be log base 5 of 5 to the, 8th power. Okay, in this case, you've got something else that's matching up, but it's the base on the log and the base on the argument. Those two things are matching up. Like I have here, log base 5 of 5. Okay? When those match, they cancel out. And the answer is that exponent right there. So what would be the answer to this one? 8.
What if the base doesn't match?
No, if one's a 5 and one's a 2, then it's totally different. Can't do it out. Not in your head, usually. Okay, so it's a special trick when those two numbers match up. That cancels out, and the answer is whatever number is right there. All right, any question on that? What form is this equation in? Is this a log equation or an exponential equation?
Both.
Yeah, it's kind of a mixture of both. But what's the first thing you see in the equation? What word?
Log.
Log. All right, so this is a log equation. It happens to have an exponential as the argument. Okay? But here's your 3 things. There's your base. That's the number that's by itself on the other side. There's your argument. Okay. What I want to do is rewrite that. Okay. Instead of writing it with the word log, let's get rid of the word log. Okay. And watch what happens. What's your base here? A, what I circled in red. That's what's lower than everything else. That's your base. Logarithm always equals what kind of number? Exponent. That's your exponent. So you've used the A, you've used the R. What's the only thing that's left? A to the R, what I circled in blue. We used what's in red right here. We used what's in green right here. Now we're going to write what's in blue, A to the R. All that this second rule is saying is that something equals itself. Of course. Something is always equal to itself. It's like if I said, does the number 2 equal the number 2? Yeah, they're the same thing. All right. So if you have the same thing on both sides, they're equal to each other. You probably didn't recognize it because it was written with the word log. But if I said to you something like this, of course you'd recognize that. Something always equals itself. Okay. Logarithms just kind of rearrange properties you already know that are true, things that are almost common sense. But you don't recognize it because it has the word log in it, and that's new for most people. All right. So this is just the reason why this formula is true. Okay, third formula. It says log base A of 1 equals 0. In other words, you can take the log of any base you want. If the argument is a 1, the answer is always 0. Always. And you already know this rule. You don't know it written this way, but you do know it written in an algebra 1 kind of way. What's your base in the equation number 3? A. Logarithm always equals what kind of number is 0? That's your exponent. And if you take anything and raise it to the 0 power, what do you always get? You always get 1. This is a very simple algebra 1 rule, even pre-algebra. Anything raised to the 0 power is always 1. That's all that this rule is saying. Just written a little different than you're used to seeing it. Okay, and the last special rule we'll see. Log base A of A always equals 1. So as long as the base and the argument match, the answer you're always going to get is 1. Let's rewrite it. Let's see why this one's true. This is another basic rule. I guarantee you everybody already knows this rule, just not written this way. What's your base here?
A.
Yeah, which one?
A at the bottom.
The red, yeah, one circled in red. A is your base. What's your exponent? 1. If you take anything and raise it to the first power, what do you always get back?
1. Like the same as everything.
You get the same thing, right? Anything raised to the first power is itself. Raising something to the first power is like multiplying it by 1. It doesn't change it. It's like adding 0. It doesn't change it. So hopefully that's a rule you already knew. Raising something to the first power gives you back what you started with. Okay? So this is the reason why this rule is true. Okay? On your reference sheet, I would just focus on writing down those rules. I'm not going to ask you why they're true. All right, so they're just special patterns we're going to look for. All right, so first one. It says 2 raised to the log base 2 of pi. Anyone think they see which special pattern this one is? 1, 2, 3, or 4? Yep, that's 1. Yep. In this case, A is 2, and M is pi. So what's the answer? Pi. Yeah, the answer is pi. Good. Okay, how about example 1b? What property is that?
2.
That's property 2. You have a log, and the base match. 0.2, 0.2. So what's the answer to that one?
-4.
-4. The answer is whatever number is the exponent on the argument. Okay, now example C, that one's a little tricky. For this one, it helps to know what ln means, because ln is hiding something. And if we rewrite what it's hiding, you'll see which property it is very easily. What's the long way to write out ln?
Log base E.
Log, I'm going to change that. Log base E. So what I just circled, those two things are exactly the same thing. Now fill in the rest of it. E to the kt is your argument. Which property is that now?
2.
That's property 2. You have a log, and you have a base and a base that match. base and the base on the argument match. When you write it as an ln, the base is hidden. You don't see that. Okay. So this is what we learned yesterday. By rewriting it, you make it more visible. So what would be the answer here? K times t, yeah. This time we don't have a number. We don't know what k and t are, but it would be k times t. Let's see, I didn't put one up for examples 3 and 4. We can do one of those. What would be log base 5 of 1? This one I'm looking for a numeric answer. 0. Yeah. It's rule 3. Log base anything of 1 is always 0. Doesn't matter what the base is. 5, 12, 37 and a half. Okay. A can be anything. If your argument is 1, the answer is always 0. Okay. Any question on that one? All right. So there's one of each. All right. So this will be the last thing we do. So for the rest of the class, we're going to look at how you can take logarithms that are separate and combine them, or ones that are already combined and split them apart. And there's only 3 rules for combining and splitting logs. This is one of them. If you have the log of a product, an example with numbers, like 4 times 5. You can take that and split it apart into 2 logs. Notice the first thing is when you split it apart into 2 logs, the base on each log that you split it into is exactly the same as the base you started with. Okay, so that base will never change for the whole problem. When you have a product, like m times n, it splits apart as a sum. So a product splits apart as a sum. You're going to have a log in each part. The base is going to match what the base was originally. Your first argument comes from your first factor, m. Your second argument comes from the second factor, n. So if you did this with numbers, log of 4 times 5, it'd be the log of 4, that's my first factor, goes as the first argument, plus the log of 5, that's my second factor, becomes my second argument. Okay, and this one I'll show you out on the calculator just because it's the first one we're doing. To keep it simple, I'm just going to press the log button when I do it. What base am I assuming if the base is not written? 10. Okay, I'm doing it with base 10 because it's fast for me to do it. I could do it with any base you really want me to do it with. This is just the fastest. There's the log of 4 times 5. Okay. Now take the log of 4 plus log of 5, and you get exactly the same thing. What is 4 times 5? 20. What's another way to split 20 instead of 4 times 5? 2 and 10. So that should also work, and that should also give us the same thing. Any way you can break up 20. 4 times 5, 2 times 10, 2 times 10. Okay, that works. You could do 40 times 1/2. That's also 20. Anything that works. Okay, so the point is a product splits as a sum. Base stays the same all the way through, whatever the base is. Okay, the next one is going to be a fraction. Well, if a product split as a sum, what do you think a fraction will split as? Well, a product didn't split as a product, so a fraction won't split as a fraction. But think about product split as sum. Division would split as subtraction or difference. Yep.
That's what he said.
Oh, I thought you said fraction. So subtraction. I got you. Yeah, you were right then. All right. It probably just confused you. Yep, subtraction. Right, this time the base was a to start. When you split it into 2, the base stays as a. When it's a fraction, remember it's subtraction. Your first argument comes from the numerator. Your second argument comes from the denominator. Okay, so if you wrote it out with numbers, you could do something like that. I'm not going to type it in. You could try it. It works. So the log base a of 4/5 becomes log base a of 4 minus log base a of 5.
Would you have to solve that, or you just leave it like that?
There's nothing we could actually solve here because we don't know the base.
Mhm.
Sometimes there might be something we can simplify a little bit. Kind of like if you had a problem here that was like the bonus question I gave you. You might be able to do something in your head, but in general, if you pick random numbers, you're not going to be able to do it in your head. The directions on the test will be very clear what you need to do. Okay, so that's the second rule. And the third rule. Third rule says that if you have an exponent on an argument, you're allowed to take that exponent and move it in front. You're allowed to take that exponent and put it in front. So as an example, if you had log base 10 of 3 to the 5th, you could take that 5 and put it down in front. And it would become 5 times log base 10 of 3. You could try typing that in if you want to type it in, and that'll work. Now, I wrote every one of these with the word log. You can also do them with ln. Nothing changes. Everywhere you see the word log on this page, you can write in ln instead. Remember, ln is just a log. It's just a log that has a base of e. That's the only difference. All right? So like if you had ln of 4/5, you could absolutely just write ln of 4 minus ln of 5. Just like we did log 4 minus log 5. Exactly same rules. Okay, any question about that? We could take that exponent and put it in front. All right. And the last thing I'm going to remind you of, the book assumes you already remember this from algebra. I'm not going to assume you remember it. When you write something as a square root, there's a way to write it without using the square root, but instead writing a fraction as a power. Does anybody remember what fraction is equal to square root when you write it as an exponent? Well, start with square root. When you think square, like square root, what number do you think of? Jimmy? 2. Yeah, it has something to do with a 2. It's not raised to the 2, though. It's raised to the 1 over 2. That's something you need to remember from algebra. So if you take square root of 9, what should I get when I hit enter? 3. If I take 9 and raise it to the 1/2 power, what should I get based on what I just said? I should get 3 and I do. Okay, so raising something to the 1/2 is the same as taking the square root of it. Okay, why would you want to change it to a 1/2? Well, because if you have an exponent, you can put the exponent in front. That's where that will come out. All right, for the rest of the class, we're just going to practice some examples, splitting and combining. Last thing I'll show you a trick on your calculator, how you can type some of this stuff in and not have to do what you did yesterday. Okay, so if you have your calculator, maybe in the last 5 minutes, I'll show you a quick trick to type in some stuff that, I don't know if it's in the book, but it'll help you out a little bit. All right, so the directions here say write this as a sum or difference. And it says don't leave any exponents. That's what this means. Express all powers as factors. That means make sure you do rule 3. Don't leave an exponent. Put it in front as a factor. Okay. I don't think you're going to have to worry about rule 3 on this problem. Okay, so let's start with this one. When we split this one apart, is it going to split apart as a sum or difference? Yeah, it's going to be a sum because you're multiplying two things together. So I'll start with that. What's going to be the base on each of those logs? 4. The base doesn't change. It stays exactly what it originally was. What's going to be my first argument? 3. Second argument? X. Done. You know, they get a little harder than that, but that's the basic idea. That's how you take a logarithm and you can split it apart into 2. Right, let's try this one. Example B. Log base 2 of 5 times r cubed. Now don't get confused if there's a power. Just look at what's in the parentheses. Are you multiplying things together or are you dividing things? You're multiplying. So this is going to be a sum. Log, log. The base is going to stay exactly what it was originally. It's going to stay as a 2 and as a 2. Okay, what's my first argument going to be? 5, good. First argument's a 5. What's the 5 being multiplied by?
R.
R what?
R to the third.
R to the third. Okay, that's my second argument. But now the second sentence in the directions tell me to do something very specific. Do not leave exponents. Take all powers and write them as factors. Are there any powers here that I can move to the front?
Third.
The 3. So that's the last step. Let's see if I can just move this up a little bit. Okay, so rewrite it. First part, that one was fine. Second part, take the 3, put it in front. Okay, on a multiple choice question, if you stopped at the second step right here and you chose that as your answer, okay, that could be a choice, but I would mark this one wrong. You've got to do this last step. You've got to put that 3 in front if it says to do this. Okay, so don't make that mistake. Okay, let's try example C. Mariah, am I multiplying or dividing inside here? Dividing. So when I split this apart, what's going to happen this time? Well, our choices are sum or difference. This time it's a difference. Okay. What's going to be the base on each log? 9. Good, that doesn't change. Okay, Chelsea, argument on my first log? X. Good. Argument on the second log? 2. And you're done. Okay, so far all the ones we've done, you pretty much could do them in one step. Even example B, you could do that in one step. You could move the 3 in front. And let's try that here. Okay, example D. This time they're doing an ln. So just make sure you write ln's instead of logs. Okay, Jen, are we multiplying or dividing here? How would you pronounce that? What's inside those parentheses? Y cubed, yeah. Can you give me another word other than over 8? Divided by 8. So what are you doing here? Oh, you did?
Yeah.
All right. So when you divide, what are you doing? Are you adding or are you subtracting?
Subtract.
Yeah, this time you're subtracting. Okay. Anyone think they can tell me what this first one is going to be? There's actually 2 things you need to do. Okay, you could start by writing it ln of y to the third. And then what are you going to have to do with that 3? Move it where? Yeah. Let's do both in the same step. So instead of writing ln of y cubed, take the 3 and put it in front right away. Okay, and then the last part, we just have to figure out what goes here. Just put the 8. And you're done that. Okay, so any question on those types? Those are like one step, pretty much you can do it real quick. All right, let's try, I think I have 2 more left. Let's just go right to F. Let's try that one. Well, you guys want to do E or F? Do either one.
Do that.
Want to do F? Okay, F's the hardest one. Although if you just look at it one step at a time, you're just going to do each thing one step at a time. Okay, look inside these parentheses. Overall there, do you have multiplication or do you have a fraction bar in there too?
Division.
Yeah, you've got division. All right, so you're going to subtract 2 things. It's going to be the log of the top. So it's the square root of x squared plus 1 minus the log of everything that's in the bottom. Since there's multiple things in the bottom, let's group it all together with parentheses. So I just put log of the top minus log of the bottom. Okay. Use subtraction because you had a fraction bar. So now at each step, you're going to be simplifying it and kind of breaking it apart. So you're not going to have as much complicated stuff in each part. Let's take the first one. The square root of something. We talked about this earlier. Instead of writing the square root, what else can I use?
Don't those cancel off anyways?
Not when it's addition. If it was multiplication, yes. Yeah, but not with addition or subtraction. Yep, what would you put as an exponent? You'd put a 1/2. Okay. Taking the square root of x squared plus 1 is the same as raising it to the 1/2. And the reason why we're going to put that 1/2, you're going to see in a second. Okay. And then once we do something with that 1/2, that part is going to be done. Minus. Now look at the log you have here. Do you have multiplication or division?
Multiplication.
Yeah, you have multiplication. How would you split apart multiplication? Is that a sum or difference?
Sum.
That's a sum. Okay, it's going to be a sum of 2 things. Put a log in each part. The first thing you're multiplying, that's your first argument. X cubed. This is almost done except the 3. We have to do something with it, and we'll do that in the last step. Okay. Next part is x plus 1 to the 4th. Okay, the reason I put these brackets around it is because you're subtracting everything that's in those brackets. Okay. If I didn't put a bracket around it, I wouldn't be subtracting the second one as well. Okay, you're subtracting that whole thing. Now my last step, what do I got to do with all the exponents? Yeah, where do we move them? To the front. So if you just want to erase them on yours and move them all, I'm just going to rewrite it. So it's 1/2 log base A, x squared plus 1, minus 3 log x, plus 4 log x plus 1. If you can do that one, that's the hardest one. Nothing gets any harder than that. Okay, any questions on that? Okay, and I did it the hard way first. I think splitting it apart is harder because you're starting out with something that's all nice and combined, and each step you're spreading it out more and more and more. If we start to take something like that and recombine it, then it gets simpler and simpler at each step, rather than getting more and more complicated. Okay, so I think recombining is easier than what we just did. Yep. Okay, when you recombine it, you're going to use all the same rules you just did, except now you're doing it in reverse. think about the last thing you would have done to get this as an answer. That's going to be the first thing you do to go in reverse. Okay. What do you think the first thing you'd do here is?
Bring that back.
Put the 4 where? Yeah, move the 4 back as an exponent. Okay. The last thing you would have done would be to put it down in front. Now we're putting it back. Okay, we're going to combine it into a single logarithm. So when we're done, I only want to see the word log written one time, not multiple times. So log base A of 7 plus log base A, what's it going to become?
3 to the 4th.
3 to the 4th. Any question on that step? Okay, next step, I would do out 3 to the 4th. Okay, rather than leave it, let's just find out what that is. Log base A of 3 to the 4th, that's 81. Just double check it. 81. Okay, now I've got one step left. I have 2 logs and I have a plus sign between them. If 2 logs are split with addition,
And multiply.
originally the 7 and the 81 were multiplied together. So it's log base A, 7 times 81, which is 567. We'll do that out. If you want to use your calculator for that, that's fine. And that's it. So we've recombined it into a single log. Now there would be no way to split that apart again. You wouldn't know how to split it. It's like if I asked you to split the number 40. Well, you could do 20 times 2, 10 times 4, 8 times 5. You don't know how to split it. So once you recombine it, it's together and you don't separate it again. Okay, question on that? All right. What do you think the first thing you'd do here is? Yeah. Let's see if we can do this whole problem in one step. What would you put back as an exponent? The 2 on which letter? The u. Okay, so you're going to have u squared. And now, what does subtraction mean? It means division. So originally you had division. What's going to go in the top? U to the second. What's going to go in the bottom? V. Done. That's the whole problem in one step. Now, you might see something in the book like u is greater than 0, v is greater than 0. They might write that sometimes, and all that means is they want you to understand u and v would never be negative numbers. Okay? Because if v was a negative number, we'd have a problem. You cannot take the log of a negative number. So if you see something like that in the book, all it means is u and v are positive. You don't have to think about them being negative, otherwise you'd have imaginaries. We're not doing that. All right, let's just go, let's go to this one. Yeah, this one looks like it could be really awful, right? 4 different logs, you'll have to recombine them. I bet we can do this whole thing in one step. When you recombine it into one log, what's going to be your base? A. It's going to stay the same. Now look at the first 3 terms. Something plus something plus something. When you have plus, how does that mean they would recombine? Multiply. We have an x, we have a 9, and we have an x squared plus 1. Okay, multiply them together. I'm going to say 9 times x. I'm going to write it that way. Times x squared plus 1. I multiplied the 9, the x, and the x squared plus 1 because they had plus signs originally. Now how about minus 5? What does minus mean? Division. What are we going to divide by? 5. You're dividing by that last argument in the log. That's it. That's the whole problem. Any question on how we did that? Okay, if you wanted, you could distribute this out. You could write it as 9x cubed plus 9x. I would leave it factored. I think that's fine. Everyone feel okay combining and splitting logs? Okay, biggest thing I'll see on a test is there'll be a problem with a square root, and somebody will leave the square root in the final answer. I'll give something like this. I'll say 5 times the square root of x. And they'll recognize, okay, he's multiplying, so it should be a sum. Okay, they get this far. And they leave that as the final answer, and I mark it wrong. Anybody tell me what is wrong with that? Yeah, what's wrong with that square root? What can you do with it? Right. You can make it x to the 1/2, and then the 1/2 can go in front. So this is what I'd be looking for. You can rewrite that as x to the 1/2 power, and then put that 1/2 in front. Don't leave it like this. To get credit, you got to leave it like that. All right, so everybody have their calculator?
I don't have mine.
Have it? Okay, let me grab a calculator. This part, you're going to have to use a calculator on the test, so I just want to spend a little bit of time making sure people know how to type stuff in, okay, which buttons to press. Okay. Who else needs a calculator? Okay. All right, so yesterday we talked about 2 bases that you can do on the calculator, no problem. What's one of the bases you can type in on the calculator? Because there's a button for it. E. Yep, there's a button for it right there. It says ln. What's the other base you can do? Besides E. Which one? Well, yeah, it's the log button up above it. What base is log? 10. That's a base 10, okay, if nothing else is written there. So you can do base E, and you can do base 10. Okay? Well, there's a lot of other numbers you could have besides an E and a 10 in the base. You could have any positive real number that you want. What I'm about to show you is how you type something in on your calculator if the base isn't 10 or E. Okay, and you don't need a graphing calculator to do it, just need a calculator that has a log button. That's all you need. So if you want to type something in, log base A of m. A and m can be any positive numbers you want. The way you type it in is you type in the common log, or base 10 log, of the argument, divided by the common log of the base. And you have the common log button on your calculator. Okay, so I'll show you an example with numbers. If you don't have a common log button and all you had was a natural log button, you could also type it in that way. I would not recommend writing both of these down. I would do it one way or the other. They will come out the same, and I'll show you that. But either do it this way, using logs, or do it the bottom way, using ln's. Let me show you an example. Okay. Log base 5 of 12. I don't have a button for base 5 on my calculator. So if I want to type this in, I can type it in as log of 12 divided by log of 5. Okay, let's type it in together. Make sure you get the same thing I get. Okay. Log 12 divided by log 5. Okay. Everybody get about 1.54. Okay. That is the correct answer. You know, some of you might have decided to type it in using the ln button. That's also fine. Natural log of 12 divided by natural log of 5, exact same thing. Just have to remember, the argument goes in the top. Base is the one that goes in the bottom. Okay, so how would you type that one in? Log base 3 of 16. Yeah. Log 16 divided by log 3. That's it. Log 16. You got to make sure you close that parenthesis. If you don't, bad things are going to happen. Okay. Divided by log 3. By bad things, I mean you'll get the wrong answer. All right. 2.52. Okay. As long as you know how to type that in, that's a super easy problem. Okay, there'll be 2 or 3 of those on the test. And that's all you have to do. Okay, so any questions on those 4 properties we started out with? The combining, splitting, or how you type this in on your calculator? Okay, some people ask me, there is another way you can type this in. If you have one of these fancy calculators, I don't think it saves me any time, but I can press a few buttons, and it gives me a special log that I can type in anything I want for the base and argument. I'm not sure this really saves me that much time. Okay. But I can type it in directly on that calculator. Okay. On the test, though, the calculators that I just passed out, those are the ones you'll be using, so you've got to know how to type it in this way. Okay. All right, so the homework, it's on 485. Okay, so for 7 to 15, just do the odds. 31 to 33, that's all. 31, 32, 33. Some of these you don't have to show any work for. You just have to use the properties I gave at the beginning of class and write the answer. So there's no work to show. And then finish up with 39, 40, 51, 52, and 65 to 69, just the odds. Okay? You will need a calculator for 65 to 69. That's what I just showed you right at the very end.